Lego's great? When I was little, I would love building towers of Lego blocks in different patterns. One pattern I liked was this. I started with 8 Lego blocks, and then had 4 orange blocks, and then 2 yellow ones, and 1 green. Right now I have a whole 15 blocks. Wow, 15 is 8 times 2 minus 1. I wonder if that is a coincidence or not. But right now, I am focusing on building my tower. I can imagine adding half a block to this, and then a fourth of a block, and then an eighth of a block, and I can keep going forever. Would this make my block tower infinitely tall? I feel like it would, since you keep adding stuff, but then the stuff we're adding keeps getting smaller and smaller, so maybe the numbers we're adding are so small that it stops somewhere and it never reaches infinity. What do you guys think? I think I'll try out a poll here, so please put your opinion in the poll so you can see what you guys think will happen. Well, I don't know how to find this out, whether it becomes infinitely tall or not infinitely tall, so I'm just going to leave that aside for now and keep playing with my tower. Actually, what if I made another tower, but in this tower each color is half the size of my first tower? I'm changing the colors because I ran out of blocks here, but the purple part's going to be 4 blocks, and then the next part's going to be 2 blocks, and then the next part's 1 block. Here I only have 3 colors because I ran out of space early. We can see that this tower has 1 less color because it's missing the 8 at the bottom. But if I wanted to make them have the same amount of colors, I could add a half a block at the end. Now it has the same amount of colors, but it's missing the 8 block at the end, and it has a half a block at the top, and those are the 2 differences from the first tower. But a weird thing happens if you imagine a fourth of a block and then an eighth of a block and so on forever at the top of both of these. There's no extra color at the end of the second one, but it still has the same number of colors as the first one. In the regular tower, we removed a color at the top to make it the same amount of colors. Sorry, we added a color at the top to make it the same amount of colors, but in our infinity tower, we're not adding a color at the top at all. We have the same amount of colors, but the first one is removed. There's no extra tower color at the top. And if you believe me, you can move on here, because talking about infinity gets kind of weird. But otherwise, if you would like an explanation, keep listening, because I'm going to go on a bit of a tangent here, but it's pretty interesting. So, why don't we have an extra color at the end? Well, this is something that's pretty hard to, accept. You want to think that, okay, if you're dividing it by half, then whatever the last thing is at the very end of the infinity, the second tower will have a half of that at the top. But that's not the case just because there is no end. If there was a number and you could have a half of it, it's going to be on the first tower too. And that seems kind of weird, okay, I get that it doesn't end, but surely there should be an extra one on the second, or it should go infinity and a bit further. But it doesn't, and there's no real, at least from my understanding, there's no satisfying way of explaining this. It's just, that's the nature of infinity. Because it goes on forever, you can, even if you divide everything by half, you'll still have the same sizes. You won't have any smaller size than the first one. But why is it the same size? So you can't really measure the size of things the normal way when you have infinite things. But there are 2 main ways you can compare the size of 2 different infinite sets. In this example, we'll say that each tower is the set of all the colors in the tower. So we're also going to call this color not red, but 8, just because I'm going to be comparing things in these 2 towers, and it's really easy for me to compare numbers instead of comparing colors. So these towers, you can say they have the same cardinality if I can come up with any function that takes this tower as its input or domain and has this tower as its output or range. And I can come up with a function, and I can also come up with the function that does the opposite. It takes this tower as its input and has this tower as its output. Well, for the first one, I can just use the function I used to make the tower. Each color in this tower is half of a color in this tower. And then to go backwards, you just take each color in this tower and you double it. So they have the same cardinality because we just made a function that goes back and forth. What about ordinality? Ordinality is the same thing as before, except now you have to preserve the order of the set, which is math speak for saying that your function can't take a color all the way here and make it a color down here. Each color has to stay in the same place. And our function does that. Each block stays in the same spot when you half it or double it, so these towers have the same ordinality too. So now we know this cool weird thing about infinity, which tells us that when you half the tower, it's the same thing as just removing the 8 in the front. So the whole tower minus 8 is half the tower, which means that half the tower is 8. So the whole tower is just 16 blocks tall. Even though we add blocks forever, the total tower is just 16 blocks tall. So I hope you guys found that cool, because I definitely found that cool. And I know you guys probably don't think, oh wow, this is a mathematical introduction to sequences, but it's definitely more mathematical, at least in my opinion, than the first chapter of your textbook. If I wrote this all down in the notation your book would use, everything we just did, that looks really complicated, right? Well, that's what we just did. Writing it in these terms is meaningless for you to learn what's going on, because you're not used to all the notation, so you get lost in the notation, and we can't focus on the really cool stuff that's going on. So, I hope you enjoyed this video, and you keep this in mind as you learn more about sequences and sums, that this is what's really going on behind the scenes, even though there's all this annoying notation going on in the front. If you want to learn more interesting stuff about infinite sequences, ViHeart is a really popular channel that makes really cool math videos with really cool diagrams and drawings and stuff, so you should definitely check that out. But for now, that's all. See you next time!